What's the right number 2? All right, Lalani can do number 2. What about number 3? Number 3? Somebody, anybody? There's 9 of you. These aren't hard questions, guys. So if you're going to volunteer right now, might be the right time, right? Yikes. 8 of you here, and 6 of you don't want to write the answer to number 3. Nobody? Nobody? Okay, let's take a poll. Who's actually here this morning? I actually can hear my voice. 5 of you. All right, so most of you are here. You just don't want to do number 3. All right. Well, Noah, would you do number 3, please? So why he's right number 3 in chat? Why do you think I'm bringing these 3 points up? Why do you think? Yeah, they were on part 2 of the test. And the fact that I'm bringing them up tells you what about the part 2 of the test of people putting their answer? Why would I bring this up? Other than it's on part 2. Not many people did it the right way. Yeah. Guys, I'm bringing this up because a lot of you are not writing your answers correctly. And by the way, I'm a teacher in math that I read all of your work. And if I can't follow it and I think you cheated because you don't, I'm making the assumption that you cheated because you're not showing your work. Not saying that you did, but to me, looking at it, I'm like, how do they go from here to here and not show any work? I'm like, I can't do that. Not saying that you can't, but if I can't, it's likely that you can't either. So if you don't show your work, I won't give you credit. And even though you'll have the right answer, I won't give credit for it because you don't have the work, especially if your work is wrong. So, guys, when you write your x-intercepts, these are coordinates. It's going to be in the form of x comma 0. And then for the y-intercept, it's in the form of 0 comma y. So just putting the number for the x-intercept and a number for the y-intercept is not a complete coordinate. So a lot of you are doing this, and I am putting notes. I'm just getting tired of putting the same note in everyone's submission. So that's what I'm going with right now. And, hopefully all of you who haven't submitted part 2 yet, or maybe you did submit part 2 and I gave you notes. Remember, you get 2 submissions. So look at my corrections. Make your corrections and resubmit before I can regrade it. So just so you know, if you forgot, you get 2 submissions for part 2. All right, number 2 says, when writing the answer for a whole, what form should my answer look like? X comma y. So again, some of you are just putting, either you're putting just the x value or just the y value or something totally just strange. I don't know. And again, I need to see your work. A few of you are going right to the answer, which tells me you probably Googled the question, or maybe use like photo math or something, and you're given the answers. And don't like that. That's considered cheating. I will give you a 0. So lack of work tells me you cheated. Whether you did or not, that's just the assumption I make. So don't take it personal if I make the assumption that you are cheating. Just show your work. All right. So the last one, when writing asymptotes, HA, VA essays, guys, VA, remember these are equations. Some of you are just writing the number, and I'm like, I know I've said this many, many, many times that these are equations. VAs are in the form of X equals, HAs are in the form of Y equals, and SAs are in the form of Y equals, right? And MX plus B, this could just be a number. I don't think this is kind of expanding on a line. This may or may not. Well, no, Noah's right. So like B could be 0. I was gonna say you could just have Y equals MX, but B would be 0. So yeah, this would be the correct form of SA. But I think on your part 2, I don't think there even was an essay. I think you actually got none. So people are actually watching this video here. You got a freebie. There's no essay for number 3. I think it is. Yeah, freebies. Not that it was it was. The freebie was the fact that you can identify there was no essay. That should have been the freebie, but double freebie by me confirming, right? So question was, could we put Y equals a number for the intercepts? The answer is no. So intercepts, I would like you to put as a coordinate. So this tells me, for one, that you actually know how to write a coordinate. I've had one person, they have their points plotted correctly, but when they actually pulled out the coordinate, I don't know what they were doing. So this tells me that you actually know how to write a coordinate. But I know in some textbooks, they can say the y-intercept is, y equals a number, but I'm telling you, I want it as an intercept form. All right. So yeah, I'm very picky on the TGA for this unit. Well, I think most TGAs. Also, I re-uploaded the document yesterday because somebody pointed out that I didn't put a blank graph on there for you for numbers 2 and 3, and you did have to graph it. It was part of the rubric. And some of you, even though in the directions it did say graph it, you didn't show your graph. So I couldn't, you got 0 points for that part of the rubric. So I re-uploaded it. I did put blank graphs for both of them. If you wanted to re-download, if you haven't done the part 2 yet. But yeah, guys, don't Google, don't search these questions. You may find answers to them. Unfortunately, people have posted on different websites, but I do look at those. I do look at the work for those, and my memory is pretty good when I recognize people copying and pasting answers that they found on forums. You will get a 0. All right. All right, let's go on to today's lesson, which is the first day of Unit 2. This is our matrix unit. We are doing elementary row operations. So I would say this is kind of like the foundation to this unit. We really know we really need to know how to do row operations. Now, did any of you do matrices in Algebra 2 or Algebra 1? Just curious. I don't remember if you do or not. Okay, so it looks like a bunch of no's. Yeah, okay. Just curious. All right, get your paper, pencil, and calculator if you need it. So we need to know how to add, subtract, multiply, and divide. This is all very basic skills, right? All right, matrix dimensions. All right, the size of a matrix is determined by its dimensions, m times n, or m, sorry, not m times, m by n. All right, so this is a matrix. You probably seen these in the past. Have you seen these? This is different size matrices. Those look familiar to you at all? Okay, it looks a little familiar. Yeah, those are matrices. Now I put a picture of a RC Cola can. Do they still make RC Cola? You still see this in stores? Anybody see RC Cola in the stores still? Not recently, but do you recognize RC Cola? Do you know what RC Cola is? Some say no. Okay, well, if you don't know, well, there is a soda called RC Cola. I want to say I haven't really seen it in stores either, but this is a soda. Well, I have RC Cola on there because the matrices is rows by columns. So to determine the dimension of your matrix, it's rows first and then the columns. So remember the rows are going left to right. So this is a row, this is a row, this is a row, this is a row, and this is a row. This is a row, and then we have a bunch of rows here, right? All right, and then the columns. Think about columns hold up buildings, right? Roofs, the next floor. So columns are vertical. So this is a column, and this is a column. All right, so the really easy one, right? What is the dimension of this first matrix on the far left? It's a 2 by 2, right? Not a trick question. There's two rows and there's two columns. Yeah. All right, the second one. What is the dimensions of the second one? Remember, rows by columns. So you actually, even like when you count, you may actually want to use your finger and just like count and say, all right, here's a row, here's a row, here's a row, here's a row, right? So how many rows and how many columns? Yeah, this is 3 rows and 2 columns. Yeah, this is 3 rows and 2 columns. So, those of you that may have missed this, remember this is a row, this is a row, and then this is a row. So we have 3 rows here. And then the columns, remember columns are vertical. Here's your first column. Here's your second column. All right. What is the dimensions of our third matrix C? Looks like we got some 1 by 3s. Anybody else? We got three out of 8 people want to participate in class. You come to the live session and don't want to participate? Is it because you're afraid to be wrong? Is that why you don't want to participate? All right, and the ones that didn't answer, yeah, nobody answered. Okay, so maybe you just fell asleep. All right, let's ask this question. Who's actually still here with me? Who's listening and you hear my voice? Okay, so 6 of you out of the 8 people that are here answered. Oh, 7 people answered, but only 4 of you answered in chat on that last matrix dimensions. So the 3 of you that are still here, still hear me. So why don't you like to give your 2 cents of what you think the answer is? Is it because you're afraid to be wrong? Is it fear? No response. I'm talking to a wall right now. Okay. One person responded. Thank you. Oh, we just woke up. My brain does not work. Okay. Fair enough. So thank you two of those four people that gave me a reason to kind of help me understand of why I'm not hearing from you. The other two. Mm-mm-mm. All right. The last one. What is the dimensions? Looks like we got four people, say five people, say 4 by 3, 4 rows and 3 columns. I would agree with you. I would agree with you. Yeah, we have 4 rows and 3 columns. All right. So how are we feeling about recognizing rows and columns on a matrix? Yeah, this is kind of, it's very basic, but it's super important to understand the rows and the columns. All right. So some of you are still with me. All right. Okay, so the entry identification. These are also called elements or an entry. So you might hear me say element. What's this element or what's this entry? They mean the same thing, and you can denote an element in a matrix by using the subscript. Actually, that should be capital A, not lowercase a. Oh, well. Sorry. Yeah. So in math, capital and lowercase letters mean different things. This should actually be a capital A. Sorry. So A sub 1, 2 versus A sub 2, 1 versus A sub 3, 1. Again, the first one is the row number and the second number is the column number. So it's kind of like if you ever played Battleship as a kid, or maybe still play it, you can play the actual game, the physical game, right? It flips up, you put your things on, and you're like E5, right? Oh, you hit my battleship or whatever. Same idea. Same idea. This is just row and column. So with knowing that this is the row and this is the column, think about this matrix here. I want all of you to go to row number 1, column number 2, and put your finger on it, so you can actually the more senses you involve in your learning, the more you're going to learn, the more you're going to retain. Just looking at it, thinking of it, you're just really just using sight and thinking, cognition. But when you bring in your body movements and you point to stuff, it does reinforce it. So everyone, go to row 1, column 2, and then go ahead and type in chat what the element is, and go ahead and hit enter for me. Looks like we got a bunch of threes, and you would be correct. You would be correct. Yeah, row 1 is this row, right? Row 1 is this one. And then column 2 would be the second one. So it puts us right here. All right, the second one, A sub 2, 1. So row 2, remember RC Colo, row 2, column 1. Everyone, what is that number? Ooh, we got lots of 9s. All right, and then what's the last one? A sub 3, 1. Row 3, column 1 is the number 2. All right, looks like everyone got them right. Nice job. All right, how are we feeling about these? Identifying the element based on the subscript. Feeling pretty good. So far, Unit 2 is looking pretty nice, right? All right, so I'd like all of you to do these 8 problems very quickly. I'm going to give you all, I think 45 seconds. We'll do a minute. We'll do a whole minute and give you time to maybe even write it down, right? We'll do a minute. And after the minute, I'll take volunteers to write these answers. Hopefully, everyone will want to write an answer on the board. We have 8 people. We have 8 problems. How great it would be if everyone participated on this page. It would make me happy, if that matters to any of you. Okay, matrices have an infinite number of rows and columns. Well, oops. So I guess technically, yes. There's not a notation to represent that. So if you go into the computer science field, programming, and it's very common to use a matrix when storing data. Is a table. It's all it is a table of data, right? Like an Excel sheet is just a matrix, right? Rows and columns. And an Excel document has an infinite number of rows and columns. Well, actually, there is a limitation, but theoretically, yes, it should go on forever, right? So I guess technically, yes, it could be infinite. In the programming world, they're called arrays. So they don't call them matrices; they call them arrays in programming. And you can have something called a dynamic array, where when you define the size of it, you can dynamically grow that array, that matrix, to be whatever size. So technically, yes. Ooh, Alani, don't give away the answer. It's supposed to be tricky. All right. All right. Any volunteers for the first one? So Lalani. So let me let me just number these so we actually know what I'm talking about here, right? So we'll call this 1, 2, 3, 4, 5, 6, 7, and 8. Okay, that way we're on the same page. All right, Lalani, go ahead and do number 1. How about number 2? You can, say me in chat or raise your hand and I'll see it. Naomi, number 2. Noah, number 3. Number 4, anybody? Ian, number 4. How about number 5? All right, Lalani, number 5. Ryan, number 6. How about number 7? Any takers? All right, Natasha, number 6, and then Lalani, number 7. All right, got new people. And guys, it's okay to be wrong during class. I don't expect any of you to always be right every single time. That's why we're in class. We're here to learn this, not to be experts the first day you see it. So don't feel bad if you write the wrong answer, you give the wrong answer. This is where we are learning it. No one should be an expert right now. All right, let's take a look at these. So row 4, column 2 is -6. I agree. 1 and 1. So yeah, I agree with that one. Row 3, column 3. Yeah, look at this. So row 3 is here, but column 3, we're not even on the matrix. So yeah, so this would be none. You could say none. You could say invalid. You could say null set or null. There's even a symbol to represent it, but I'm not going to show it. I don't want to confuse you guys. Number 4. So row 1, column 4. Yeah. So, this one was, I think, pretty clear to see. There's none, even if you mixed up rows and columns. This one, you could have easily done like, you could have thought maybe column 1 and then row 4 and got it backwards, right? So I would expect some people would have put -5 by accident. But yeah, so row 1, column 4 would be over here, which, there is also none. So nice job for those who did 3 and 4. Number 5, this matrix here. So row 2, column 2, so -1, nice. Row 3, column 2 is a 5, very good. And then row 1, column 3 is a 3. And then row 2, column 1 is a 2. Nice job, everyone. Perfect. All right, how's everyone feeling about picking out the elements, giving the notation? Pretty solid. Pretty solid. All right. Now let's move into some actually the operations, the part of the lesson we actually care about here. So this was the goal, is to perform these row operations, but we really had to get that basic info out of the way. That way we're all on the same page here. And these really aren't that much harder. But understanding the notation, super important, because we're actually going to apply this on our next couple lessons that we're going to have. All right. So switching 2 rows is this notation. When you see this double arrow, they are saying we are switching these 2 rows. So you are switching row 1 with row 2. Which row doesn't change? I'm asking a very obvious question here. Yeah, row 3 doesn't change. So what I do is when I see something like this, I usually write the row that that we're not changing, just so I don't mess it up. So we're not changing row 3, so I just go ahead and just write that down so I don't make a mistake later. With all of these elements, it's very easy to make a mistake. We have 9 numbers here we have to write. All right, so if we're switching row 1 with row 2, well, we just do exactly that. 0, 1, 5 is your first row. And then -5, 2, 3 is your second row. It's really that easy. So row operations, we can swap rows. By the way, these are the 3 operations that we can do. We can swap rows. We can multiply a row by a scalar. We can also add 2 rows. And this is probably the hardest one. I'm going to explain when we get there. All right, so looking at this, when multiplying a row by a non-zero constant, we're multiplying all the elements in row 1, in this case, by a 2. So again, which row or rows do not change in this matrix? Yeah, row 2 and row 3. So I like to I just like to write those so I don't, make a mistake later, right? It's we just copy row 2 and row 3. They don't change. All right, and then go ahead and what do you think what are the elements in row 1 going to be after we multiply them all by 2? We got -10, 4, and 6. Yeah, nothing difficult, right? So we have we can multiply a row by some constant that's non-zero. All right, so it looks like the first 2 are pretty easy operations. This last one, there's a rule we have to remember. So when I say add row 2 and row 3 together, looking at this, which row do you think doesn't change? Which row do you think does not change? Row 1, that'd be a good guess. Yes. Yeah, row 1 does not change. And we know that for a fact because we're not actually using it in any operation for this. So yeah, row 1 doesn't change. So I'm going to go ahead and just, oops. Oh, I gave it away. Pretend we didn't see that. Dun, dun, dun. All right. So also, row 2 does not change. And we know that. So when you have an operation, whether you're doing, a row plus or a row minus another row, the row, so write this down, the row that changes is the one that's listed last. So even though we're doing row 2 plus row 3, we are only going to change row 3. So that means row 2 just gets copied over. So when you're doing, whether you're adding or subtracting two rows together, the row that changes is the one that's listed last. That is super important. So all we're going to do is, well, take this number plus this number plus this number, and then this number plus this number. So based on what I just said, what are these three numbers? So we got -1, 7, and -4. People are saying in chat, and I would agree with you. Yeah, so if you're paying attention, this isn't hard, right? All right, this is easy. We just had to know that the row that's listed last is the one that's going to get the change. And we are going to add the element in row 2 to the element of row 3. So 0 plus -1 is -1. 1 plus 6 is 7. And then 5 plus -9 is -4. All right, how are we feeling about row operations? Good. Very good. All right, let's try these. So I have this matrix, and I want you to perform these three row operations. So let me give you all 1 minute. I think 1 minute should be enough to probably do these. We might need like a minute and a half, but we'll do a minute. All right, the first one. The first one, which rows don't change? Row 1 and row 3. Yeah, row 1 and row 3 don't change. All right, for the second one, for the second problem, which rows don't change? Row 1, 2, and 3. And for the third one, which rows don't change? So again, that third problem we have, which rows do not change? So some say, okay, so let me ask it a different way. Based on what's written here, which row is changing? Which row is changing? So we got some R3s. We got a lot of R3s. Let me go back to this previous page. So remember, when you have a row operation like this, whatever is listed last in the operation, that's the row that changes. So it's not the last row in the matrix, it's whatever's listed in the actual operation. So row 3 is listed last in this operation we're performing, so that means row 3 is changing. So I think maybe a couple of you misunderstood when I said last. So I meant this in the operation, what's listed last, which is R3. So again, looking at this, any of you want to change your answer of which row is changing? R3. There you go. There you go. So that means row 1, 2, and 4 stay the same. All right, so far, is everyone on the same page of which rows just get copied over? All right, good, good. I got to make sure in the next class at 10:30 that I be very specific so it's not misunderstood. All right, good. All right. All right, going back to this one, what two numbers go here in row number 2? -5 and -6. Yep. Means that's -3 and 4. All right. The middle problem. What is that that fourth row? -15 and -18. Yep. All right. And then what is the row for our third problem? 4 and -3. I agree. I agree. All right. Very good. All right. These are the last 3. We have time, right? Oh, yeah, we have plenty of time. So let's do. Was 1 minute enough for everyone? Just curious. Was 1 minute enough? You want a little bit more time? 1 minute's fine. Okay, we'll do 1 minute again. All right, ready to go. All right, the first one, which rows don't change? Which rows do not change for the first one? Row 2 and 4. Rows 2 and 4 do not change. Yep, I agree. All right, what is row number 1? What are those elements? 3 and -4? I would agree with you. Yeah, those are super easy. Swapping rows, really easy, right? All right, the middle example, which rows do not change? We got 1, 2, and 4. Yeah, it looks like we're all in agreement on that. 1, 2 and 4. All right. So what are the two elements for that third row? -12 and 16. I agree. All right, now the tough one. All right, the third example. Which rows do not change? Which rows do not change? So some of you are saying only 2 rows don't change. Others are saying 3 rows don't change. Looks like everyone is at least in agreement with row 3 and 4. Yeah, rows 3 and 4 don't change. I agree with you. Um, so what is the what is the elements in row 1? What are the elements in row 1? So we got 2 and 2. Anybody else want to agree or disagree? So some of you are saying it makes sense that it's 2 and 2. Naomi says she thinks it's just 1 and 1 because 2R1 is only added to row 2. I think that reasoning makes a lot of sense. Anybody else? So I'm going to give you a little hint. Well, let's do this. What are the elements in row number 2? What are those elements? So we got a lot of -1 and 6. Looks like, yeah. So -1 and 6. I would agree with you. So remember, when you're adding or subtracting, you do the operation and only the second row in the operation gets changed. So, like Naomi says, we are doing 2 times row 1, and then we are adding that to the row 2. So we look at this, right? 2 times 1 is 2, and then 2 plus -3 is -1. And you may want to write that out. I didn't show my work, but if you're missing that, you really should write down 2 times 1 plus -3, 2 times 1 plus 4. 2 times 1 is 2, 2 plus 4 is 6. So going back to answer what is row 1. Now, I said on this previous page, when you're combining 2 rows together, you only change the one that's listed second. Even if you have a scalar in front of them, it doesn't mean you change that row permanently. So the only time that we can actually change a row with a scalar is if I actually give you a scalar multiplication like I do here. I'm telling you do -4 times row number 3, right? So that is the only time that we are just changing that row with that scaling value, that coefficient, that constant. So even though we're using it here, this only gets applied to the solution for row number 2. Does that make sense? So with that said, what are the elements in row 1? Yep, 1 and 1. 1 and 1. 1 and 1. So again, even though we have a scalar here, it only applies to this addition of these 2 rows, and only row 2 gets changed. So this is also why I like to copy down the rows that are not changing, because if you don't do that, it's a somewhat common mistake that people will do 2 times row 1, and they'll accidentally change this row because they wrote in the rows last. So again, only row 2 is changing in this operation. So we're just going to copy row 1, row 3, and row 4 because they're not changing, right? And that way we know at least those 3 rows are correct. And then we just have to do this operation. You know, we're doing 2 times row 1 plus the row 2, we get -1. 2 times row 1 plus the 4 gives us our 6. All right, how are we feeling about this? Good, good. Okay, so for those of you that are here, I will be absent on Monday. So what I'm going to do is have the I could cancel the lesson if I want to, but I think it's important that we have live lessons. Personally, I like the way that I explain stuff versus the modules, for each their own, of course. But I want to have the lesson we're going to have Monday later this afternoon. So just give me idea if you want to make that live lesson this afternoon. Give me the time block that I could schedule this so you can make it. And again, I can't make everyone happy, but I'm going to try to schedule it so that all of you can come. So give me like, if you're free from noon to 4, put noon to 4. And then I'll choose the hour, right? So I need the actual block, the block of time that you are free to attend the live lesson. If you plan on it. If you don't plan on coming to the live lesson, you're going to watch the recording later, then just don't respond in chat. All right, so I'm going to ask my other class, and just look for the Class Connect session that'll appear sometime, probably before noon is when I'll schedule it. So yeah, just look for the Class Connect. And hopefully it works for your time schedule. If not, you can always watch the recording later. But again, I'm going to do the lesson later today that we would do on Monday, since I'll be out Monday. Yeah, and I'll record it, of course. Yeah, I'll record it. I will record it so you can always watch it later. All right, everyone. Well, thanks for coming. And as always, I hope you learned something. I will see you all, well, some of you later today.